In this lesson, we will learn a step-by-step method for graphing general sinusoidal graphs, functions of the form, and also this form. For a sinusoidal function, we'll look at four key values: period, amplitude, phase shift, and vertical shift. Let us consider this example. Then the values are: on the x-axis, we need to plot the points where the function completes one cycle. Since sinusoidal functions are periodic, we need 2 points, the starting point and the ending point of a cycle. These are found using the following formula. Substituting the values, and let's say we want to graph 2 cycles of the function, then we choose n equals -1, 0, and 1. This gives us the following cycle points. On the graph, we now have a set of guide points to use in the next steps. Next, we draw the line y equals -1. Now, let's plot the cycle points along this line. Semicycle points are the midpoints between consecutive cycle points. We can find them by taking the average of their x values. Both the cycle points and the semicycle points lie on the line y equals -1. These are the intersections of our function with the midline. We now plot the lines that mark the maximum and minimum values of the sine function. They are given by these equations. Now, substituting the values, next we continue the calculation, and this gives us the maximum and minimum lines. To determine the maximum and minimum values of our function, we compute the quarter cycle points. These points are the midpoint between the midline intercepts. Here they are shown on the graph. Next, we draw the vertical broken lines through these points. These lines, together with our earlier guides, will help us graph the function. Starting from the first cycle point, we draw the graph rising from x equals -pi to x equals -5π/6 concave down. Then it drops to the next y equals -1 intercept, still concave down. Next, the curve decreases further to its minimum at x equals -π/2, this time concave up. From there, it rises again to the next cycle point, completing one cycle. The pattern continues indefinitely. Now, let's look at another example of a sine function. As before, we compute the 4 key values: the period, amplitude, phase shift, and vertical shift. From these, we determine the cycle points. The midline y equals 2, and then we plot the cycle points. Then the semicycle points can be obtained in a similar fashion. The maximum and minimum values are obtained in the same procedure. Quarter cycle points and the vertical broken lines can also be determined in the same way. Since the coefficient of sine is -3, the graph is flipped, and so the maximum and minimum are swapped. This time we draw the curve downward from the first cycle point, moving toward the next minimum point. The rest may be continued in the same way to complete the cycles. We've completed our examples with sine. Now let's turn to cosine. The steps are the same, but there's a subtle difference in how the graph begins. Here are the key values for this example. The cycle points are obtained in the same way as before. In this case, the cycle points are shown here. The midline is y equals 3, and here are the cycles plotted. Next, the semi-cycles. Then the quarter cycle points, along with the vertical broken lines. Now we add the maximum and minimum lines. For cosine, the rules of the points are clear. The cycle points are maximum values, and the semi-cycle points are minimum values. And the quarter cycle points are the intersections with the midline y equals 3. The graph of a cosine function starts at the maximum at the first cycle point. From there, it drops down to the first intercept with y equals 3. It continues downward to the semi-cycle point, which is a minimum, but concave upward. Then it rises, still concave up, passing through the next midline intercept. Finally, it increases to the maximum, this time concave down, completing the cycle. Repeating this pattern gives us the graph of the function. And that completes our lesson on graphing general sinusoidal functions. We've seen how to find the cycle points, the semi-cycle and quarter cycle points, and how to use the midline, maximum, and minimum lines to shape the graph. Thank you for watching, and I hope this walkthrough helps you practice graphing sinusoidal functions on your own.